On page 101 of the Student Journal, section 4.3, continuing with lines, we're going to talk about how to write equations of parallel and perpendicular lines. Before we can even do that, how can you recognize lines that are parallel or perpendicular? So as a reminder, parallel lines, lines that never intersect, they have the same slope. Perpendicular, let's see, perpendicular lines that intersect at one point and are are perpendicular to each other, form right or 90-degree angles. One other detail about perpendicular lines, slopes. So for parallel lines, they are lines with the same slope. For perpendicular lines, the slopes are negative reciprocals of each other. So what do I mean by that? A negative means if it's positive, it becomes negative. If it's already negative, it becomes positive. You just change the sign essentially. For reciprocal, you just flip the fraction. So 2, let's say one slope is 2. To get the negative reciprocal of that, well, really 2 is 2 over 1. And to flip that, that goes up to the numerator, that goes down to the denominator, and it's positive, so it turns negative. So negative reciprocals for slopes are 2 and negative 1/2. This is just examples. Another example might be, let's say I started out with negative 4 over 3 as my original slope. The negative reciprocal would be, well, it goes from negative to positive, and 3 over 4. So essentially you write a fraction, you change the sign, whatever the sign is, it doesn't matter what it is. If it's negative, it becomes positive. If it's already positive, it becomes negative. And then the fraction just switches. So that's how you find negative reciprocals. We're going to move on, give you guys some concrete examples. So all vertical lines are parallel. Why is that? Because if you just look at that, it should be kind of obvious that they're never going to touch. Two distinct non-vertical lines are parallel if and only if they have the same slope. So again, that was part of our notes earlier. Parallel lines have the same slope. Let's see here. Two lines in the same plane that intersect to form right angles. So earlier I think I wrote perpendicular to each other, right angles are 90 degrees. Notated by this little box right here. If you see that, you can assume, or you're being told, that this is a 90-degree or right angle. So vertical lines are perpendicular to horizontal lines. That should be kind of obvious. They form a cross of sorts. Pretend these are straight. And yep, that's it. If you take a second and look at these, perfect. The example earlier I did was positive 2 to negative 1/2, but it doesn't really matter as long as the signs are changed and you take the reciprocals. So the negative reciprocal of negative 2 is positive 1/2. The negative reciprocal of positive 1/2 is negative 2. Notice that this has nothing to do with the y-intercept b and everything to do with the slope. The number in front of x. Alrighty. So determine which of the lines, if any, are parallel. So again, we have to have the same slope. So let's just identify some slopes. So we have 3 lines, A, B, C. We'll say A, we're going to find the slope of that. B, we're going to find the slope of that. And C, we're going to find the slope of C. So if we're looking at A, we have up 1, 2, 3 over 1. So we have up 3 over 1, 3 over 1, that's just 3. For line B, we have up 1, 2, 3, 4 over 1. So 4 over 1 is 4. And for line C, we have 1, 2, 3, 4 over 1. So now we see that which of these two numbers are the same? 4 is the same thing as 4. So we can say lines B and C are parallel because they have a slope. They have a slope of 4. Here, we're going down. Sorry, this is line A, B, C, and again, we're just trying to find the slope of each of these. If the slopes are the same, they're parallel. If they're not the same, they are not parallel. So down, starting from line A, down 1, 2, 3, 4 over 2. Down is negative, down 4 over 2, negative 2. For B, it is down 1, 2 and a half over 1, minus 2.5 over 1 is equal to negative 2.5. And lastly, for line C, I have down 2 over 1. Down 2 over 1. It doesn't look like any of these fractions are the same. But negative 2 divided by 1 is negative 2. So I can see that indeed lines A and C are parallel. Lines A and C are parallel because they have the same slope, negative 2. Okay, so for number 1, I had a really simple graphic representation of this that enabled you to just count. For line 3, or sorry, for numbers 3 and 4, you're actually going to have to find M using arithmetic. So you'll say x1, y1, x2, y2. So I won't work out number 3 for you, but it is definitely going to be a little on the tedious side. You could just watch me go because I don't really have too much to say. Again, the formula for M is y2 minus y1, and trust me when I say by the end of this chapter, you should have this memorized. Y2 minus y1 over x2 minus x1. So for instance, what do we got here? We got, this is A first. Let's do A first. So I have 2 minus negative 1. So y2 minus y1 divided by x2 minus x1. So I have, let me make this line so you see it's like a fraction. 2 plus 1 is 3. 2 plus 4 is 6. So M is equal to 1/2 for A. But I'm not finished. I have to find it for all 3. So for B, it is y2 is 1 minus y1, negative 3, over x2, 5 minus negative 5, x1. Again, make it clear that this is a fraction. So we have 1 plus 3 is 4, 5 plus 5 is 10. If I reduce this or simplify it, I can divide both the numerator and the denominator by 2. So I have 2 over 5. So these are not the same. And lastly, we'll look at C, the slope of C. Negative 1 minus negative 3. If you don't understand what I'm doing, I'm literally just using this formula right here. y2 minus y1. y2 minus y1 over x2 minus x1. So negative 1 plus 3 is positive 2. 2 plus 2 is 4. Why am I adding when it says subtract? Because it's subtracting a negative. So I have 1/2. Ooh-wee. So then you could see that lines A and C are parallel because they have the same exact slope. So that's your proof. You could say, just like we did earlier, lines A and C are parallel because they both have slope 1/2 or 0.5, whichever. So let me erase some of this so that you can see it. No, you can't. But yeah, if you're listening along, then you got it. If not, listen. Just turn up the volume. Okay, so before we can do any of this, we have to find the slopes. Again, the slope is the number in front of x. However, y has to be isolated. So for a, I'm going to subtract 9 on both sides. I'm going to say 4x minus 9 equals negative 3y, and then I'm going to divide everything by negative 3. So I have negative 4 over 3x plus 3 equals y. This is line A. The slope is negative 4 over 3. For B, you just gotta divide by y. Or sorry, you gotta divide by 8. So I'll divide everything by 8. I'll say y equals negative 6 over 8. I can divide both those numbers by 2. So I'll say negative 3 over 4x plus 2. M in this problem is negative 3 over 4. So those are not the same. Let's see if C is the same as either of those. I'm just going to divide everything by 4. So C is right here. Y is equal to negative 3 divided by 4x plus 9 over 4. Now don't forget, we do not care about the intercepts for parallel lines and perpendicular lines. We just care about the slopes. So what is this the same as? Negative 3/4. Negative 3/4. Lines B and C are parallel. Lines B and C are parallel. They both have slope negative 3 divided by 4. You know, if you want to write a fraction, I recommend you do that. Number 6 is exactly the same. You work it out on your own to get M. Write an equation on a line that passes through the given point and is parallel to. So I know if it's parallel, it has to have the same M. It has to be. It just has to. And because it's giving me a line, what form do you guys know where you can use the slope and a point? Oh, that's right, point slope. So as a reminder, that's y minus y1 equals m times x minus x1. So here we got y minus negative 1, which is plus 1. We got 1/3 x minus 3. We could stop there. This is point slope form. If you want to make it slope intercept, you could subtract 1 from both sides. Say y equals 1/3 x minus 4. This is the again, this is the slope intercept form, much more common than point slope form in SATs or any standardized test really. Next we have y minus negative 2, which is y plus 2, minus negative 2, I'll show that there, equals m times x minus 1. Oh no, you dope. I'm so sorry, I forgot to put parentheses around this. So, it's my mistake. Glad you guys are here with me to catch it. Glad I caught it before I just put this up. You have to distribute this before you can subtract 1. So I have 1/3 x minus 1. 1/3 times negative 3 is negative 3 times 1 is negative 3. Negative 3 divided by 3 is negative 1. I'm actually going to stop right here. I'm going to say this is a plus 1 still. I will say this is a plus 1 still. I'm not editing this out because it's good that you guys, I mean, it is good that I made a mistake and caught it because now you guys know not to take anything for granted. Hopefully, those of you who are sharper already caught it. If you did catch it, you are not wrong. I should have put parentheses around it. Good for you. Again, I will subtract 1 from both sides though, and I get 1/3 x minus 2. That's the answer for number 7, the correct answer. Oops. Okay, so for this, we're going to distribute this negative 2. Say y plus 2 equals negative 2x plus 2. Subtract 2, subtract 2. bada bing, bada boom. Y equals negative 2x. And that'll be it. Okay, so there's your learning about parallel and perpendicular lines. We can have a lot more examples here, but that was the meat of the lesson, like truly. Determine which of the lines, if any, are parallel or perpendicular. So I'm just going to leave you directions here. Check if slopes m are the same or negative reciprocals. If m is the same, lines are parallel. If m is negative reciprocal, lines are perpendicular. So again, you find m just like the way we did earlier with 1 and 2. You just have to count down 2 over 1. Down 1, 2, 3, 4 over 2. Make sure you simplify up 2 over 2. Again, you'll be doing the same thing for number 11 and 12 as we did earlier. Number 13 and 14 we already did. And perpendicular, okay, so this is good. So perpendicular slopes. So right now m is 2/3. And to make it perpendicular, it's currently positive, so I'm gonna make it negative. And I'm gonna make that happen. So negative 3 over 2. So now you can say point slope form, y minus 2 equals negative 3/2 x minus negative 2, which is, so this is x1, this is y1. Y minus y1 equals m times x minus x1. So this is x minus negative 2, which is x plus 2. And let's see here. Because y is not by itself yet, we actually don't know the slope, so you have to divide everything by 2. Y equals 2x minus 3. M is currently 2. To make it the negative reciprocal, I will turn it into a fraction and make it negative now. So negative 1/2. So y minus 1 equals negative 1/2. X minus 3. I highly encourage you guys to go ahead and distribute this and add the 2. Distribute the negative half and add the 1 to write it in slope-intercept form, because that is a lot more common than point-slope form. Alright, but otherwise, that's it for section 4.3. As usual, if you have any questions, ask your teacher or let me know.